Alright, so this video is about balancing the cells. Um, in my other video, I was charging up some of the cells. Some of these came in at 3.8s, and I charged them to 3.95, 3.93, kind of trying to get them as close as possible. So some of these might have to get dropped a little bit, and some of these get pushed a little bit. But um, I'm using this iCharger 306B. I think it's used normally for charging RC batteries, lithium-ion batteries. There's quite a number of batteries that are supported here. And powering it, it needs an input of between 4.5 to 38 volts. Powering it, I'm using this power supply, DC power supply, which can output quite a number of volts, but I keep it at just about 5 and max out the amps. Right now, this is what it's drawing. So that then runs out to these terminals here, which are going to black up there, red here, so negative, positive. And we also have our, where is it? Yeah, this. So this is the balanced terminals. They have these very specific balanced terminals on the side here. Let's see here, kind of have to do this one hand. Oh, it's stuck here. All right, there we go. So this is the balance ports. Depending on how many cells you're working on, you would use a certain balance port. And right now we're doing 4 cells. So I'm gonna go ahead and plug that in. Okay, there we go. We have 4 cells because 1 cell, 2 cell, 3 cell, 4 cells. So with that, it comes out with 1, 2, 3, 4, 5 wires. So 1 wire, 2 wire, 3 that goes between those 2, 4, and then 5. With that, it's able to track. With that, it's able to track the voltages between each one. So if I was to kind of manually do this with the multimeter here, here and here. So measuring that cell in particular, that gives me about 4.7 volts. I'm trying to get everything to around 3.9, 3.3, 3.93, 94, 95, as close as possible. So that way when I install the batteries in, it will be more balanced. Less work for the BMS system to deal with. Especially when these batteries came in, some of them were 3.8, 3.7, 4.7. It varied. Like looking at this here, this one says 4.02. Let me see what this one's, some of these say 4.0, 4.06, 3.97. Yeah, there's a lot of voltages here. Want to make them as close as possible since the BMS doesn't really allow you to balance that easily. It takes a lot of work to balance. The resistors are very small. So yeah, just a few more things here. Since it's complaining about main port is these main wires here. So sorry, got a lot of red wires. So I made these connectors so that way, using these banana plugs, got them on some, kind of made my own connectors here. That way I'm able to unplug these safely whenever I'm switching between them. As you can see, they have 10mm bolts and these screws that are made specifically for these modules. And then we have one of those brackets that came from one of these connectors that used to be on the batteries. Yeah, you can see another one in here. So I just took miscellaneous one out. There's usually a couple of them. Yep, and then So with this here, single module, generally it's easiest to balance one module at a time. This thing has a maximum of 6 cells, you can balance at one go, but then that goes into half another module, and if one module is 3 and one is 4, that's a mess, but I don't want to deal with that. So one module at a time, 4 cells, trying to balance them all across. And with that, in order to just prevent like risks of like shorting or conducting things, I use these connectors that, where's the other side? Here it is. That way there's no risk in either side shorting out. You can see they're pretty much kind of covered, insulated, and only when I connect them do they actually bridge. So I'm gonna go ahead and connect it. That part to do with one hand. There you go. So connected. So yeah, in a way I kind of cut those cables and made them so that way, like the balance connectors are like look like this. I made it so that way I can switch between if I need to balance a single cell or 2 cells or 4 cells or 6 cells. I just made it so I can disconnect them. And with these I also made them quick connects, quick disconnects. These kind of came like this. If you look at it, in a way it's kind of, one side is male, one side is female. Just pretty much cut them in half and yeah, just join them together, solder them together. These are the heat shrink solders where you heat them up and they solder together. On this side I made connectors, put on connectors, just crimped them, stuck them on, and yeah, that makes it quick for me to kind of go through the cells and try to balance them. So I've been charging a bunch of cells. For charging, when using this, you kind of have to, in the settings, you have to go for the lithium batteries. Nickel cadmium, yeah, it charges a lot of batteries. So I'm doing lithium ion, and I raised it up 4.05, but if I'm charging, I actually set it down to, in order to charge, I set it down to 3.99. It's not the capacity. I'm purposely doing this because it's kind of like a middle area. Charging it using the BMS in the car is a lot faster than trying to charge it individually like this, because it takes about 5 hours to charge off of this little setup here per module, and we have about 24 modules times 5 hours. That's a good week or more, or I might be miscalculating that. 24 5, yeah, it's more than a week. Okay, so it's a lot of time. Don't want to be, and you have to move them across module to module, cell to cell. It's going to take a while. So try to kind of find a voltage point that wasn't too high, too low. That way I just kind of bring them all to that same kind of middle point. And I guess 3.93, 94, 95 is the sweet spot right now. So you set it 3.99. It won't actually charge at 3.99. It kind of drops a little bit below, and it's been 3.93, 3.95 is where it kind of settles. But in order to discharge, you can't put it too low because it's going to say that 4.07 is over voltage, so it won't let us actually discharge it. So to discharge, I actually have to bring it a little higher than the current voltage. So set it lower for charging so I can charge to a lower point, and higher for discharge. I was wondering why I was getting error messages. So actually, if I put it lower, just to show what happens, and then I exit that, go to lithium ion, not too far, lithium battery, and then now if I choose to discharge, it says balance over. It just won't let me charge it. If I actually press start to charge it, it'll say balance port cell high voltage. So it took me a while to figure out that if you're getting balance over error messages, it's because your limit over here is too low, because it's a safety cutoff. It goes into the safety cutoff to determine that it's fully charged. So lithium ion, so just set that to a higher number, and now allow us to discharge it to a lower number. So yeah, that should be more than enough. Let's just set it to 9, that's 7, we should be good. Okay. And okay, that's set. Now go over to lithium battery again. Go back to discharge. So now I'm going to discharge it down to 3.95. Here you can actually, let me see here. If you hit the start button, you can jump between the different settings, how many amps you want to pull or discharge at, what's the voltage you want to drop it to. I set to 3.95, which then ends up ranging around 3.9395 anyways. And yeah, so once we're ready, you hold start. It says that it's currently at 4.09 volts. You press this one here, you can see that each cell is about 3.12, 4.1, 4.11. So it's going to try to balance these out. Push this button again, you can see that it's running. This is how long it's been taking. When it's done, it's going to say done over here. And yeah, that's pretty much it. Kind of, in order to track it, since it takes 3 to 5 hours depending on how far it's going, kind of set up a little camera here, which then allows me to kind of see wherever I am, if it's charging correctly, and also in a sense also if it's on fire. Hopefully not, but should knock on wood. Anyways, yep, so balancing them. So let's see here, that one's done, that one's done, that one's done. This one's in progress. This one is 3.94 done, 4.04, that one needs to be discharged, 3.94, and this one was 3.97, so that one probably discharged too. So 1, 2 left other than this one, and I need to start clamping these as well. So that's going to be the next step. I'm going to clamp these cells into this thing I set up. Haven't gone to it yet. The rods came in very long, probably too long, but it's okay because we can cut them. They're at least solid, and I'll have to deal with this kind of funky welding that I did, try balancing them. That's not really balanced, but yeah. Those are going to be next, so probably going to clamp them soon because I'm going to finish these and begin charging and discharging these. Just for visual, we can see that these modules I got from AliExpress. They shipped in boxes that aren't in this garage anymore, but went through quite a beating. Kind of see like dents in the corners on the side. So far it looks like the cells are good. I don't see anything that's unusual, like other than lots of dents there. Like this is another dent right here, here. In a way, having bad modules kind of gives me an idea of like what's actually bad and what's good. So these, I mean, they look kind of bad, but it's actually not that bad when you compare them to real bad modules. These are the modules that I fried. You can see here, this one expanded so much it opened up the entire case. So these are the truly bad modules. Let's see which one this one is. Yeah, and so these are the ones I'm going to actually be dropping off tomorrow at the recycling center. Yeah, this one's expanded. Pretty much all of them expanded and became an accordion. So I'll be dropping these off tomorrow and disposing of them. But yeah, so bad modules, damaged or dented modules, but it's really just, hopefully it's just frame damage. From the charging perspective, I think one of these was dented too, but I kind of straightened them all out as I went through them. This one was one of the really dented ones as well. Straightened out these corners, and overall they're pretty good. This one's a little dented, but yeah, it's not affecting the cells. In a way, I think these are just shells that are just protecting the cells. Yeah. So yeah, that's the update.